Hello, and welcome to the Argyle CIO Leadership Forum, Building a Resilient Enterprise. My name is Nick with Argyle, and it's great to have everyone joining us today. I have some important information to share with you, and then we'll turn the floor over to our esteemed opening keynote speaker. First, we would like to take a moment to thank today's sponsor, Rimini Street. Our sponsor is committed to providing you with valuable content and a great overall experience. At any time during today's event, you can visit their virtual booth from the main agenda page, which include complimentary materials, information, and meet and greet opportunities. We also welcome you to stay socially connected during today's event. For those of you who are active tweeters, please use the hashtag ArgyleDigital and follow us on Twitter at Argyle Exec Forum. Also, be sure to follow Argyle on LinkedIn for special announcements. I would like to take a moment to touch on our content neutrality policy, which we have curated based on the feedback we have received over the years from our members. We have worked closely with our speaking faculty to ensure that you receive a set of balanced and neutral viewpoints during the session today, and we appreciate our members' support of this policy. Finally, and most importantly, we want to hear from you. So during each session, we encourage you to submit your questions and comments in the Q&A box on your screen. Following each presentation, we have set aside time for our speakers to weigh in on your questions. Thank you again for joining us today. Now, let's get started. Without further ado, I would like to introduce Sujit Bambwale, Chief Information Security Officer, 7-Eleven. We're excited to have Sujit with us for his opening keynote presentation titled Cloudy with a Chance of Breach, the Now of Cloud Security. Welcome, Sujit. Over to you.
Thank you very much. And it is an honor to be here speaking to this esteemed audience. My name is Sujit Bambawale, and thanks for the wonderful introduction. I've spent my entire career focusing on information security and various different parts of information technology. And the move to the cloud has been one of the most significant moves, a tectonic shift, if you will, in this space. I think the current bias towards AI will be reminiscent of a similar change. But for now, at least in the world I've seen, the move to the cloud has been the biggest change I've seen so far. In the cloud, where we are today, we are past all of the lift and shift dialogue. We are past all of the I am moving to the cloud dialogue. We are past most of the my data center no longer exists. Now we are completely in the cloud dialogue. And I remember that time, 5, 7, maybe even 10 years ago, when a lot of folks were discussing the move to the cloud. They were discussing, well, how could we do it? What are the considerations? Will it really work? Is it going to really save us money? And so on and so forth. In the last several years, lift and shift has not only become easy and scalable, but it has also led to the proliferation and the pervasiveness of cloud native applications and frameworks that use the true power of the cloud, the true elasticity of the cloud, which then brings us to what is most important in our context, which is cloud-based resiliency. Cost is a byproduct. What most organizations focus on is being resilient, is being available at all times, promising the same high level of performance all day, 24/7, to each and every one of their customers. From a cloud standpoint, getting into the rhythm of promising every customer 100% uptime, or as close as we can get to 100% uptime, and making them all feel that we are available at all hours to serve them, I think is the best outcome. And today, where we are, the journey that we have been coached through by all of the applications that we deal with, all of the customer experiences that we deal with, We want to bank in the middle of the night. We want all our applications to be available all of the time. In fact, I would say when customer service is sometimes unavailable in whatever middle of the night time zone we are speaking from, that time it is almost seen as an inconvenience. And we think, well, why aren't they available now? Why aren't they up when I'm up? Some think of it as fair, some think of it as unfair, some think of it as, well, they should just scale to where we are. So that's the customer expectation today. Resilience is a very key characteristic of the customer experience today. Slow is the new down. I think I'm borrowing that phrase from a t-shirt I saw somewhere. Now, cloudy with the chance of breach. All of this move to the cloud, all of this consideration for cloud cost frameworks, cloud elasticity frameworks, cloud resilience frameworks has had a balancing factor. And that balancing factor that has balanced or has tempered our velocity to move into the cloud and to really go cloud native, as they say, has been balanced with several news about, and this is what this slide will really talk about, a fair amount of news from the security standpoint. Before we go there, though, let me talk a little bit about where we are today. On the left-hand side of this slide, you'll see that the current compound annual growth rate for cloud adoption. My slides really want me to move past this one. I don't know why. The compound annual growth rate on cloud adoption at the very top left of this slide talks about a huge forecast. I'm very fortunate that a lot of this data is available online. This one I got from marketsandmarkets.com. And I was really surprised to see that as of 2022, the compound annual growth rate for cloud adoption is 545 billion with the B. And it's projected to hit that huge number that you see on the other end of this slide by 2027. Now, what that tells us is that we're not just on a strong path ahead, a robust path ahead, but we're also on a very high velocity path ahead. The bottom left of this slide, this looks at the compound annual growth rate of cloud native applications. And this is really, this makes me smile, because we're not just getting into, I am in the cloud, I'm lifting and shifting into the cloud, I am adopting the cloud. But this trend, the 23.7, says we are really harnessing the power of the cloud. We're putting the cloud to work for us for performance, for elasticity, for what the user is really looking for and what enterprises are looking for. The market opportunity over the next 5 years, significant. We are at 5.9 billion now. It's 17 billion over the next 5 years. And the key market players, again, from marketsandmarkets.com as a source, rated IBM at the top, Amazon, Google, Microsoft, and VMware. I was hoping to see Oracle on that list. And I'm sure, a lot of people would say, well, Oracle is on that list, VMware is not. Amazon should be at the top, Google should be at the top, Microsoft should be at the top. And, I think that competition is good and healthy in any space. I know that no conversation about the cloud can almost occur without talking about AWS or Azure. And GCP, the Google Cloud Platform, is coming up in a very big way nowadays. But on the right-hand side of this slide, I think that's the tempering part, that's the balancing part that I spoke of. These are, and I'll go from top to bottom on them, these are the biggest cloud security breaches of 2022. FlexBooker is a travel company. Blue Bleed, I think most of us, perhaps more in the security space, have heard about quote unquote Blue Bleed. Microsoft related. China, we saw information about 1 billion, again with the B, citizens taken from Alibaba Cloud. We had Microsoft hit by the threat actor ring called Lapsus. And they made away with not just 37 gigabytes, but also source code for Bing Maps, and Cortana. We had Medibank, which is an Australian company, and they lost information about 9 million customers. And Pegasus Airlines was not just 6.5 terabytes, but it was PII, and it was blueprints, it was flight information, it was how they measure and do telemetry for their flights. Mangatoon is an online comic book provider or adult graphic novels provider. They were compromised through their Elasticsearch database, and it was 23 million users. Puma, very popular shoe company, they were a part of the ransomware that hit the Kronos cloud platform, which Puma was a user of. And it went and compromised about 6,000 employees' data. I think one of the most interesting parts about this is Amazon itself is on this list. Amazon Prime Video, one of the key things that Amazon is known for, aside from their retail arm, of course. Amazon Prime Video was compromised as well. They leaked the records of 215 million users' viewing habits. And finally, Civicom, which is a conferencing company, a video audio conferencing company. They lost about 8 gigabytes of private conversations, transcripts, and so on and so forth. Now, a recurring theme here is for FlexBooker, for Pegasus, for Civicom, and of course for Amazon. It was an Amazon S3 bucket. Alibaba Cloud, Azure, Microsoft are also figuring on here. So if you were to kind of heat map this list, you'll see a lot of AWS and Microsoft. And that's not to point fingers or to blame. We're all in this together. So this needs close scrutiny so that we can all learn from it. So the reason both of these things are on this slide is because I want to start by saying, yes, there is high velocity. Yes, there is high demand. Yes, there is high spend. But we also have to look at the data. And the data also says there is a high incidence of security breaches. There is a high incidence of high volume, wide impact security events in this space. Let me hit play and hope it goes to the next one. Okay. Now, with this, and I talked about going cloud native as one of the key benefits. Okay. I talked about going cloud native as one of the key benefits of moving to the cloud. So it's not just about lift and shift. It's not just about stair stepping or moving up the ladder, or if you consider it up, sideways, that's personal preference. But going from the data center to the cloud, maintaining a hybrid environment. Some organizations have chosen to keep the data center as well as the cloud and move workloads depending upon a cloud governance model and so on and so forth. But the real performance benefit of going into the cloud is having a cloud native application framework using highly elastic, high performance applications that use the distributed cloud native framework. Now, this gets talked about a lot, and this gets talked about again as a benefit. So on this slide, I've talked not just about the benefit and what a distributed cloud native framework looks like, but also to balance it with what could be concerns in a distributed cloud native framework. So in a distributed cloud native framework, I'll go through the list on the right. The first thing that could happen is network latency. And again, slow is the new down. No, none of us like latency in general, but it is very much possible. It does happen, and it can have multiple reasons. I mean, at this point, I think we have global undersea cable kind of tying together the continents today. And yes, there are issues there. There are issues on undersea connectivity. There are issues on satellite connectivity. There are issues on even local connectivity. So network latency is very much a possibility. The second is transient connectivity errors. Transient fundamentally is very short term. So think of these as short term connectivity errors. And these can be minor blips. And a blip, depending on how long that plateau lasts on the waveform, can be a concern, cannot be a concern, and can affect a microservices architecture. Then we have long-running synchronous operations, which means effectively a stuck job. So when something goes into a I'm doing something, or I'm not able to exit, I'm not able to get out with the next node, that can cause issues with even a cloud native microservices oriented framework. We can have a crashed host process in which that has to be then identified. See, in a microservice environment or in a cloud native environment, everything is its own silo. So when you have a crashed host process, we are basically losing one feature. We are basically losing one discrete capability. So a crashed host process not only has to be detected very quickly, but also has to be restarted very quickly. We can have an overloaded microservice, too much traffic, too much concurrency, too many users, any number of reasons. And we can have rolling upgrades. I mean, everyone wants to be on the latest version of everything at all times. And arguably, that's one of the benefits of the cloud, to be able to be on the latest version of everything at all times. But then that also assumes that upgrades are happening all times, rolling upgrades are happening at all times. And when that rolling upgrade hits you exactly when you're doing something or about to do something, or when your microservice is about to execute on something, that's when even your distributed cloud native environment can have an issue. Finally, at the bottom of the list, and by design, is hardware failures. This is not something that we think about a lot nowadays, about hardware failures, but hardware does fail. All hardware does have a limited shelf life. And with the high velocity of use in such cloud environments, someone had said anecdotally, the cloud is just my work on somebody else's computer. And that is true to a great degree, which means that somebody else's computer is doing work for a lot of different people, which means it is being highly utilized, which means it is being overclocked and used as much as possible all the time, which also means that that hardware is more prone to failure than any piece of computing that you have around you in your space. Your laptops may die after 3-4 years. Hardware in a clustered high velocity environment like a cloud compute data center will die out much more quickly. So hardware failures can exist and do exist. So these reasons, these instances balance out the benefits of a distributed cloud native environment. Arguably, the distributed cloud native environment is still winning in terms of it being able to offer great benefits and so on and so forth to its customers. Now, what happens when one of these things really kick in? What happens to the microservice? What happens to your resiliency? We're here to talk about resiliency. So what happens when one of these things actually manifest? So the diagrams on the bottom left, and I found these in a ebook called Architecting Cloud Native .NET Applications for Azure. The beautiful part is it's a free ebook. All of you can download it for free from Microsoft itself. And if you can't find it, please reach out and I'll send you the link. It's a completely free PDF and an ebook. And all of this is explained in much better and greater detail than here on my slides. But the retry pattern on the bottom left and the circuit breaker pattern on the bottom right, there are two very important patterns to restore services, because you can set up your microservices to continuously retry if and when any of those reasons actually manifest. But your retries should not cause by themselves a cascaded failure condition, because you've set them to just continuously hit retry, thus creating a synthetic flood of items for your applications and your microservices workflow. So you have one retry pattern that could work. And then to balance that, you have something that is called a circuit breaker pattern that can say, perform these kinds of retries, and after X many retries, stop, because we don't want to kill our own applications or our other microservices because of that flood of error messages caused by the retries. These things are very important, and they manifest at the worst possible times when you're expecting high load, high concurrency, peak season, any other things that you're looking forward to from a revenue perspective. All of those things can result in a lot of real traffic, good human purchasing traffic hitting your applications. And then you're suddenly saying, oh my God, something happened. What exactly happened? Okay, there are too many retries. Oh, the application's kind of killing itself. So microservices are wonderful. They offer redundancy, they offer resiliency, they offer a method of saying, okay, only this has failed. The whole thing doesn't have to come down, which is great for resiliency. But then there also are these considerations, these nuances of a distributed cloud native framework that we need to consider so that we actually optimize for the customer experience. I see a question here. I see multiple questions here. Okay, I'm going to take a few questions. Thank you. Is 545 CAGR or spend? It's CAGR. All of the numbers on the slide on my slide were CAGR. That's compound annual growth rate. Good question. Question number 2, with regards to rolling upgrades, how often is the need to roll back? That's a relative question. Very recently, and obviously this is not in the cloud context, I saw that Apple was 16.5.1 for iOS, then they went to 16.5.1a as a part of their rapid response security releases. And then they had to roll back, and they actually pulled that upgrade. So is there ever a reason to roll back? Yes, that reason to roll back, how often, that varies from case to case, that varies from hyperscaler to hyperscaler. Amazon may have it different, Azure may have it different, your use of it may have it different, because you're going to prioritize resiliency over whatever that upgrade offers. Now, if that upgrade is for a weaponized security vulnerability, you may not want to roll back, because you want to protect not just your customers, but also yourself and your applications and the data that is already held within your applications. So how often? I'm afraid that's a case by case or a company by company or a use by use answer. Question 3, what is the best way to handle cloud breaches, and actually the best way to discover one ASAP? Well, that's a great segue into my next slide. And my next slide, the one you see up right now, is going to talk about scaling and sharing. And I'll skim through this very quickly. Again, let me make sure that I pause on the slide. Okay. So on the left-hand side of the slide, we talk about scaling up and scaling out. And I think these are terms that are common in the cloud space, but I wanted to make sure that, I talk about these and take any questions about them if necessary. So scaling up is increasing capacity by adding RAM CPU to a single resource, that is scaling up. Scaling out is increasing capacity. Horizontal scaling is by adding resources. So that's the difference. And in a cloud context, a lot of scale is not only very easy, but an incremental cost and not a great incremental cost, which means scaling up can be done much simpler than it can be done on premises in your data center and so on and so forth. So that's the benefit. On the right-hand side, again, as a balance, the shared security responsibility is often not very well understood. So on this slide, what I've done is I've attempted to simplify the shared security responsibility model. On the left is what the cloud provider brings. On the right is what you bring. And the sub-bullets are what each one of us are actually responsible for. So the cloud provider, from a facility standpoint, they're responsible for perimeter, actually the perimeter around the cloud compute hardware, temperature, power, redundancy, maintain cooling, have always on power, have redundancy, meaning multiple zones across the globe, so on and so forth. They're responsible for physical infrastructure, getting the right server hardware, power cabling, temperature management, perimeter security, if you want actually to opt for 24/7 patrolled security for your cloud cages, it is possible. Network infrastructure, virtualization, and even the virtualization layer and continuous innovation in the virtualization layer is one of the most important things, because without a good management layer and a good optimization layer within your virtualization layer, you won't be able to get new services, learn about new services, consume new services, which is really the innovation of the cloud provider that you are doing business with and are hosting with. And on the right-hand side, you specifically as the customer, and you should take responsibility for this. That is why the magnifying glass and the icon, you are responsible for hardening or securing your operating system, or making sure that the service privileges patches are all properly done. Your applications have good identity and access management, memory management, and they're containerized properly in the cloud, which is a shared environment. And data, most important, encryption. Yes, it is very, very simple to have always on everywhere encryption right now, but it has to be actually done. Don't make it an assumption, make it a assertion. Make sure it is a substantiated assertion. Your backup, whether it is onshore, offshore, multiple regions, again, it has to be verified, and access to data is really the most important thing. Controls have to follow the data, but access is what lets the data move. So I'm going to answer the question about security. This is a long list, and it'll be difficult to go through this in the 1 minute that I have. But what I wanted to talk about on this slide is that there are a lot of top 10s, top 11s, top 5s, top 8s with regards to cloud security, and what to really focus on with regards to the top concerns in the cloud space. But the way that I've put them together is misconfiguration is at the top. If you have default discoverability and default credentials, you are going to be viewed by threat actors. Then comes strategy and architecture. And in that, I have put insecure software development and insecure third-party resources as well, because that should be a part of your strategy, and that should be a part of your architecture to vet software development and to vet third-party resources. Expertise and maintaining expertise to manage your cloud deployment and your cloud environment is also extremely important. I see a question there about best practice document to build a resilient enterprise. There is a lot of collateral on the internet for best practices, and I'm not suggesting that my session or this list is a best practices document, but I think you should get all the information that you can to build what works for you. This works for me. Account management, looking at hijacking and privilege escalation. I think that's number 3 on my list, because it is so prevalent. It is so often that I hear about hijacking and privilege escalation. Identity management for your humans, for your administrators, for your machines, and your key management, extremely important. That's why it's in the top half of my list. Abuse
Thank you, Sujit.
detection.
We
Now it
actually have
comes,
to wrap it up.
sure.
We have another session starting in about a minute and a half, but thank you so much for such an insightful presentation. And I want to thank everyone else for joining us today. And this session, along with all of today's content, will be available on demand following the event. Thank you again, Sujit, and everybody else, and we'll see you later. Have a great day.